All right, clip number 3 on Chapter 11, Section 2 notes on areas of circles and sectors. And here in this clip is where we're going to attack the second namesake of this section, the sector. So formally at the top here, what is a sector? A sector is a region of a circle bound by two radii and their intercepted arc. It's a lot of geometric language to describe this, okay? A sector is going to be that slice of pizza where it does need to be centered at the center of a circle. Because again, I could draw lots of slices. I keep leaning into this pizza metaphor, but let's say the guy at the pizza parlor cut it like really uneven and was off center. Then now we deal with different kinds of sections and stuff. But again, for the sake of this, we're going to assume that the fact that they're described by radii, meaning that it is centered at the center, and we now have a portion of a circle as shown, kind of making this Pac-Man face. Okay, this is where it's essentially an extension of what we talked about in Section 1. In Section 1, we talked about arc length. And in Section 1, arc length was simply a portion of the entire circumference, or the distance around a circle. Those are one-dimensional measurements, simply a length, described in inches, centimeters, feet, miles, whatever it might be. And that was completely contingent on what the central angle would be, basically the size of the slice given by degrees compared to the 360-degree circle. That's what this kind of fraction here represented. Based on the arc measurement, that was a topic in Chapter 10. The arc measurement, again, just tells me how many degrees this arc is compared to the 360. Essentially, this fraction, again, just breaks down as telling me what portion of the pizza this slice is. Is it a fourth, a sixth, 3/8, those sorts of things. It breaks down in that kind of fraction. Okay, and again, in Section 1, the one-dimensional measurement, it made sense that if the arc length that I was measuring was 1/4 of the size of the entire circle, then the length of that arc should be 1/4 of the length of the entire circumference. The same concept is going to apply here. It's just we're dealing with now a two-dimensional measurement, area. And so you'll notice that the formula does look very, very similar to what it does in Section 1. The difference here being the denominator, well, and numerator, but this side of the equation. In Section 1, this denominator was 2 times pi times r, the entire circumference of the circle. In this case, you'll notice it's pi times r squared, the area of a circle. So really, it's still the same concept, though. The measurement of the arc, which will either be shown outside the circle as some degree measurement, or it can also be expressed as the degree inside the slice, like you see here. Whatever that degree is represents the portion of the full 360-degree circle. So this fraction can reduce. And even if it doesn't reduce, it tells me basically a fraction, a portion of the whole circle that this slice represents. Now in Section 1, I would have been finding the length of the crust of that slice, to use the pizza metaphor again. In this case, now I'm looking at the entire area of that slice. That's what we call a sector. And so this first equation just represents that, well, if this, for instance, broke down as 1/9, if it was 40 degrees, if it was 1/9 of the entire circle, then the sector area should be 1/9 of the entire area of the entire circle. That's what that fraction would also have to match. And all this second formula here represents is that if I solved this equation for this numerator, the area of that sector, then I would simply take this denominator and multiply it out in front over here, as shown right there, the area of a circle. Couple things to point out that are similar to what we dealt with in the procedure to solve these problems in Section 1. There are technically 3 pieces of information in this formula, 3 potential variables. I say potential because depending on the information that were shown in a diagram, different things could be unknown, other things could be known, as shown in the diagram. So the 3 things are as follows: the sector area that we're going to be talking about, basically the area of a given slice. The second one would be the measurement of the arc, as shown either by the degrees at the central angle or as the measurement of the arc outside the circle. As you see here in this diagram, it's in the central angle. It's one and the same. So if this is 70 degrees, the measurement of this arc UV is also 70 degrees. But that could be something that's also unknown. And then, just like in section 1, there's some kind of combination you're going to see here. In this case, it could be radius. Okay, the radius of a circle could be known, like in this diagram. It could be unknown. Maybe it's something I'm solving for. It could also be given to me in the form of a diameter, in which case I would simply cut that diameter in half, and now I've got radius again. Or, just like we saw in section 1 where we had to solve for circumference, you're going to see one in here where maybe I have to solve for the entire area. Well, pi r squared itself is just the area of the whole circle. And so you'll see some variation of that in this clip. But those are the three things. So area of the sector, arc measurement, and then either radius, diameter, or in this case, area of a circle. Okay, so those are the three things. I should be able to pull two pieces of information out from a given diagram and solve for the third. The variations could involve some sort of algebraic phrase where maybe I have all three and I'm just solving for a variable. But let's jump into this first example. In this diagram, it's a little small, but we see the central angle here is 70 degrees. That translates to the arc measurement here for arc UV. That tells me the portion of the 360-degree circle that it is. And the other piece of information I'm given here is the distance from T to V, the center of the circle T to the outer edge V. So 8 inches here is the radius of this circle. Okay, so I'm given the R portion here. So in this diagram, I'm given the arc measurement and the radius. It stands to reason that what I'm going to be solving for here is the area of the sector, as what we're shown here. Find the areas of the sectors formed by that angle, that slice. Okay, well, let me jump to the whiteboard to go through the solution process. Again, just to blow up our diagram here, we're given a circle with a given slice. Just to use our letters here, we have U, T, V. They give us some random point S out here. The reason they do that, because the question did say find the areas of the two sectors that are created. You may think, wait, there's only one sector created, this slice right here, but technically there are two slices, right? I have this smaller slice, this smaller wedge, and then there's the leftover. The way I can find either is if I solve for this one first, which we will, then I simply subtract that slice from the area of the whole circle, and that tells me what's left over for this guy. So that will be that procedure. But then the pieces of information I'm given, just to blow it up again, this was given to me as 70 degrees, which for the record, that directly translates to the measurement of this arc, U to V. That's the portion of the 360-degree circle. And then I'm told the distance from T to V is 8 inches. All right, so just like I demonstrated in section 1, I need to identify the three pieces of information. Now, the piece I'm solving for in this case is the area of a given sector. So sector area is my unknown here. So I'll write it in a different color. I don't know my sector area yet. That's the area of this slice. That's what I need to find. That's part of the formula. The other two pieces I am given. I'm also required to find the measurement of the arc created by that slice, U to V. That was demonstrated by the central angle being 70 degrees. So that is a definitive number. And then the other piece here is that I am given the radius of the circle is 8 inches. Again, they could have given me a diagram where they gave me diameter. I'd simply cut the diameter in half to find radius. Or they could have given me the area of the whole circle, in which case, in the formula, the pi r squared would just be that number. Okay, so this part right here tends to be shown in different ways. Okay, but now, again, you don't have to write this equation. I'll go ahead and write it out just this one time. So sector area is going to equal the measurement of that arc. The letters here are UV. It kind of depends on the diagram for that. Out of the total 360-degree circle is multiplied by the area of that circle, pi times r times squared. Okay, so now I'm just plugging in the stuff I know, solving for the pieces I don't. The unknown here is this left-hand side of the equation, the area of the sector. I do know this guy, that was 70 degrees. R here is 8 inches. I'm going to plug those values in. I'll show you the exact solution as well as the approximated rounded solution. So sector area over here is my unknown, so I'll just solve for the right-hand side here. The measurement of arc UV, that was given by the central angle of 70 degrees, out of the total circle, which is 360 degrees. I'm going to multiply that times pi times r squared. R here was 8 inches. So I'm just substituting that stuff in, and I'll end up squaring that. So there's the substituted stuff. All right, I would reduce this fraction. This one doesn't reduce as friendly as some of our section 1 problems, but this does reduce to 7 over 36. So if this pizza, if I use the metaphor again, was cut into 36 even slices, the area of the sector I'm finding would be the equivalent of 7 of those slices. Or 7/36, that's the fraction of the whole pizza that we got here. And then this right-hand side, 8 squared, I can actually do on a calculator. 8 times 8 is 64. So that would be multiplied by 64 pi. I'm leaving the pi in there to keep it exact for right now. And then this is technically over 1, for the record. That's important because when I multiply fractions, I go numerator to numerator, denominator to denominator. So this comes out to be 7 times 64. Don't be intimidated to use a calculator. 7 times 64 gives me 448. So my numerator here is 448 pi. Don't forget about that pi. And then denominator, 36 times 1 is 36. Okay, next thing this is technically the area of that sector in whatever square units it was in. If I want to keep it an exact solution, I would reduce this fraction. 4 goes into top and bottom, and I will end up with 112 pi over 4 goes into 36 9 times. So this is the fully reduced exact version. But again, what I could do here, typically you're going to be asked to approximate whether you're multiplying 448 times 3.14 and the dividing result by 36, or in this case, 112 times 3.14 and then divided by 9. I'll take that 112 times it by 3.14. There's my denominator, divided by 9, because I used the reduced fraction one. If I went to 2 decimal places, this one comes out to be about 39.08 square units. And the units were in inches, so that would be the area of the sector right there. So there's the approximated version. There's the exact solution reduced. This will probably be what you're asked for in big ideas. But it essentially boils down to what we did in section 1, where I'm plugging in the stuff that I'm given, translated from the diagram, solving for the pieces I don't know. Let's do one more example. Just different information given in this one. I won't bother writing the formula down again here. I'll just jump right to plugging it in. So in this diagram, just kind of sketch it out for us here. We're given a circle, and then we're given some slice over here. Just to use letters here, TVU. And in this case, I am actually given, let me use the colors I used in the notes, that this was 40 degrees for that central angle, which again translates to the measurement of that arc. And then I was told the following. They show me a colored in version like this, and then they say this area, in other words, the area of that sector, is 35 square meters. So in this case, I'm given the area of the sector, right? Sector area is 35 square meters. This is the left-hand side of the equation. The measurement of the arc, which would be from U to T in this case, just to use the right letters, that's 40 degrees. That again tells me the portion of the pizza that it is. And the piece I'm actually solving for in this case, they said to find the area in this case. Now, for the record, A is not explicitly written in that formula, but area is pi r squared, which in my formula is that pi r squared portion. So in this equation, I'm going to have the sector area, 35 square meters, equaling the measurement of that UT arc, 40 degrees out of 360 degrees. And then I'm going to multiply, instead of by pi r squared, since I'm just solving for A, I'm just going to solve for A right there. So solving in this case, again, I just plugged directly into the formula. I reduced this fraction first. This one's a little bit friendlier than the last one. This one reduces to 1/9. On the left-hand side, it'd be 35. And so if I want to solve for A here, I just multiply both sides by the reciprocal. The reciprocal of 1/9 is times 9 over 1. So I'm multiplying by 9. And in this case, on a calculator, 9 times 35 gives me my result of 315 square meters for area.